So friends, we have previously discussed microservices interview question. So now we have to discuss further on these topic. So this is the second part. If you have not seen my first part, so I will link the description in this video for the first part also. So now we will discuss what is RESTful. RESTful means representational state transfer. It's an architectural style used in building web services. It is a set of guidelines and principles that defines how web services should be designed and how data should be transmitted between the client and server. The main idea behind RESTful architecture is to use HTTP method such as get, post, put, delete to operate on resources such as data entities identified by unique URLs. The communication between the client and the server is done through a standard interfaces, and the server does not maintain any client state. A RESTful web services must adhere to several constraints, including statelessness, client-server architecture, cacheability, layered system, and uniform interfaces. These constraints ensures that the service is scalable, maintainable, and easy to evolve over time. RESTful services are widely used in web applications, mobile applications, and Internet of Things (IoT) devices. They provide a flexible and lightweight approach to building web services that can be accessed from any platform or programming language. So moving forward, explain three types of tests for microservices. Microservices architecture involves breaking down an application into smaller, loosely coupled services that communicate with each other via API. Testing microservices can be challenging because there are multiple components to consider, and changes in one services can have unintended effect on others. Here are three types of tests commonly used for microservices. First one is unit test. Unit tests are designed to test individual units of code or small pieces of functionality in isolation. In the context of microservices, this means testing each service independently. Unit tests are typically automated and run on a developer's machine, allowing developers to catch error early in the development cycle. Integration tests. Second type of tests are integration tests. Integration tests are designed to test how well different microservices work together. Integration tests can be automated or manual and involve testing different microservices in combination. These tests ensures that the service can be communicated effectively and produce the expected result. Third one is end-to-end test. End-to-end tests are designed to test the entire microservices architecture from the user perspective. These tests simulate real-world scenarios and test how well the microservices work together to produce the desired outcome. End-to-end tests can be automated or manual and are typically run in a staging environment that closely resembles the production environment. These tests ensures that the microservices architecture works as expected and provide a positive user experience. So what are client certificates? Client certificates are a type of digital certificates used in client-server authentication to verify the identity of client. They are commonly used in secure communication protocols such as HTTPS and Transport Layer Security (TLS). Second point, you can mention that client certificates are used by trusted certificate authority and contain information about the client, including its name, public key, and the client authority that issues that certificate. When the client wants to communicate with server, it presents its client certificates to the server. The server can then use the public key in the client certificate to verify the client identity and establish a secure connection. Third point, you can say that client certificates provide an extra layer of security in client server communication. They are commonly used in application where security is critical, such as online banking, e-commerce, and government website. By using client certificate, the server can be sure that it is communicating with the intended client, and the client can be sure that it is communicating with the intended server. This helps prevent man in the middle attacks and other security threats. Explain the use of PACT in microservices architecture. PACT is a testing framework and methodology that helps to ensure that the microservices work correctly together by enabling consumer-driven contract (CDC) testing. CDC test involves defining contracts between microservices where the consumer services define the expected response from the provider service. PACT is designed to make CDC testing easier and more scalable for microservices-based applications. Second point, you can say PACT provides a way for developers to create and test contracts between services. A contract specifies the expectations of the consumer and the provider in the terms of request and response message. PACT enable consumer tests to be written in the language and framework of the consumer service, and the same test can be used to generate a mock service that simulates the provider service. Third point you can mention, when the consumer service is deployed to production, PACT verifies that the provider service responds as expected based on the contract. If the provider service does not respond as expected, the test will fail and the development team will need to make changes to ensure that the contract is fulfilled. Fourth point you can mention, the benefits of using PACT in microservices architecture include: first point is improved collaboration between the development teams. So here you can say that PACT encourages communication between the development teams by providing a shared understanding of the contract between services. Second point, we can say faster and more reliable testing. PACT ensures fast and reliable testing of microservices by ensuring that the contracts are fulfilled during testing. Third one is improved agility. PACT enables developers to iterate and deploy new features and change to microservices without breaking existing functionality. Overall, PACT is a useful tool for managing the complexity of microservices architecture and ensuring that the service works together as intended. What is the meaning of auth? Auth, open authentication, is an open standard protocol used for granting access to protected resources on behalf of a user or an application without sharing the user credentials with the service provider. Second point, auth allows to grant access to their data and resources to the third party application or services without sharing their login credentials with the third party. This is done delegating access to the resources to a third party service provider which is authorized by the user access the resources on their behalf. Third point, auth has become popular protocol for authentication and authorization in the web and mobile application. It is widely used by social media platforms such as Facebook and Twitter to allow third-party application to access user data. Fourth point, auth works by providing a mechanism for a user to grant access to their data to an application or service. The process involves a series of interaction between the user, the application, and the service provider to authorize access to the resource. The process typically involves the exchange of token between the user, the application, and the service provider. And the last point you can also mention, auth is widely used because it provides a secure and a standard way to access protected resources without sharing the user credentials. It has become an essential component of modern web and mobile application, enabling them to provide a more seamless and integrated experience for users. What is the end-to-end microservices testing? End-to-end microservices testing is a type of testing that evaluates the entire microservices architecture as a whole. Rather than testing each service in isolation, the purpose of end-to-end testing is to ensure that all microservices work together seamlessly to provide the desired functionality to the end user. Second point, end-to-end microservice testing involves simulating real-world scenarios by testing the entire system for the user perspective, including all the microservices, APIs, and external services. This type of testing typically involves a combination of manual and automated tests and is conducted in a staging environment that closely resembles the production environment. Third point, the key benefits of end-to-end microservice testing include: first point, improved system reliability. End-to-end testing can help identifying issues and dependencies between microservices that may not appear during unit testing. Second, improved user experience. End-to-end testing ensures that the microservices architecture works seamlessly together to provide a positive user experience. Third, reduced development time. End-to-end testing helps to identify issues early in the development cycles, reducing the overall development time and cost. Fourth, improved scalability. End-to-end testing helps to identify bottleneck and other issues that may affect the scalability of the system, enabling developers to optimize the architecture for performance. Overall, end-to-end microservice testing is a critical component of microservices architecture, ensures that the system works as intended and providing a positive user experience. Why are containers used in microservices? Containers are used in microservices architecture for several reasons, including: first one is scalability. Containers allows microservices to be easily scaled up or down as needed, provide a high scalable infrastructure for microservices application. Multiple containers can be launched to handle incoming requests, and additional containers can be added or removed dynamically based on demand. Portability. Containers are highly portable, meaning that the microservices can be easily deployed across different environments and platforms. Containers can be created and tested on a local machine, then deployed to a production environment without any changes to the code or configuration. Isolation. Containers provide a high degree of isolation between microservices, ensuring that each microservices run in its own containers with its own set of resources. This helps to prevent conflict between microservices and provide a more secure infrastructure. Faster development. Why containers enable rapid development of microservices with new code or configuration changes pushed to a container and deployed almost instantly. This enables deployers to iterate and deploy new features and changes to microservices. Resource efficiency. Containers are lightweight and consume fewer resources than traditional virtual machines. This means that microservices can be run on a smaller infrastructure, reducing cost and increasing efficiency. Overall, containers provide a high scalable, portable, and efficient infrastructure for microservices applications. They enable developers to rapidly develop, test, and deploy microservices while ensuring a high degree of security and isolation between services. What is the meaning of semantic monitoring in microservices architecture? Semantic monitoring is a type of monitoring used in microservices architecture that focuses on the meaning and context of the data being monitored. It involves analyzing and interpreting the data produced by microservices to detect and anomalies and gain insight into the behavior of the system. Second point, traditional monitoring tool typically focuses on metrics such as CPU usage, memory usage, and network traffic. While these metrics provide valuable information about the performance of the system, they do not provide a complete picture of the behavior of the microservices. Third is semantic monitoring. On the other hand, provides a more comprehensive view of the system by analyzing the data produced by microservices and interrupting its meaning and context. It involves using machine learning algorithms and other advanced techniques to identify patterns and anomalies in the data, enable faster detection and resolution of issues. And fourth point, the key benefits of semantic monitoring in microservices architecture include: first is improved system reliability. Semantic monitoring can help identifying issues and anomalies in the behavior of microservices that traditional monitoring tools may miss. This can improve system reliability by allowing issues to be detected and resolved before they become critical. Second is faster incident response. Semantic monitoring enables faster incident response by identifying issues and providing details insight into the behavior of the system. This enables developers to quickly diagnose and resource issues, minimizing downtime and improve the user experience. Third is better insight. Semantic monitoring provides a more comprehensive view of system, enable developers to gain insight into the behavior of the microservices and identifying opportunities for optimization and improvement. Overall, semantic monitoring is a valuable tool for microservices architecture, providing a more comprehensive view of the system and enabling faster direction and resolution of issues. What is CDC? CDC stands for Change Data Capture. It is a technique used in distributed systems such as microservices architecture to capture and propagate changes made to data in a database or other storage systems to other components that need to know about those changes. CDC allows microservices to subscribe to changes in the database or other data source and receive update in the real time. When a change is made to the data, the CDC system captures that change and publishes it to message queue or other channels where the subscribing microservices can consume it. The key benefits of CDC in microservices architecture include: first one is reduced coupling. CDC helps reduce coupling between microservices by enabling them to receive updates about the changes in the data they depend on without having to query the database themselves. Second is improved scalability. CDC enables microservices to scale independently of each other by allowing them to subscribe to only the data they need rather than querying the entire database. Real-time updates. CDC enables microservices to receive real-time updates about changes in the data, enabling faster response time and improving the user experience. Fourth point you can include reduced complexity. CDC has reduced the complexity of microservices architecture by providing a simple and effective way for microservices to share data. Overall, CDC is a valuable technique for microservices architecture, enabling microservices to share data in real time and reducing the complexity of the overall system. What is the use of Docker? Docker is a platform for developing, packaging, and deploying applications using containers. Containers are lightweight and portable units of software that can run on any operating system or a platform. The key benefits in the case of Docker include application development. Docker is used by developers to build and test applications in a local environment before deploying them to production. Docker makes it easy to create a consistent development environment that can be easily replicated across different machines and platforms. Application packaging. Docker enables application to be packaged in containers which can be easily distributed and deployed to different environments. Containers provide a lightweight and portable way to package application along with their dependencies and configurations. Third, microservices architecture. Docker is a popular tool for building and deploying microservices architecture. Container enables microservices to be isolated from each other, improving security and reducing the risk of conflicts. Fourth, cloud infrastructure. Docker is widely used in cloud infrastructure to enable the deployment of application on different cloud providers. Docker containers can be easily deployed to cloud platforms such as AWS, Azure, and Google Cloud. The key benefits using Docker includes first one is portability. Docker containers can run on any platform or operating system, providing a consistent and portable environment for application. Scalability. Docker enables application to be easily scaled up or down based on demand, improving performance and reducing cost. Third is efficiency. Docker containers are lightweight and consume fewer resources than traditional virtual machines, improves efficiency and reducing cost. Fourth one is isolation. Docker containers provide a high degree of isolation between application and microservices, improving security and reducing the risk of conflict. Overall, Docker is a valuable tool for developing, packaging, and deploying application using containers, provide a consistent and portable environment that can be easily replicated across different machines and platforms. How independent microservices communicate with each other. Microservices are designed to be independent and loosely coupled, which means that they should be able to communicate with each other without depending on a specific technology or platform. There are several ways that microservices can communicate with each other, including first one is REST API. One of the most common ways for microservices to communicate with each other is through REST APIs. Each microservices can expose a set of REST APIs that other microservices can use to access its functionality. Second is messaging. Another way for microservices to communicate with each other is through messaging systems such as RabbitMQ, Kafka, or ActiveMQ. Microservices can use messaging queues to send and service message, which can help decouple them and improve scalability. RPC. RPC stands for Remote Procedure Caller, is another way for microservices to communicate with each other. In this approach, microservices can expose an API that other microservices can use to invoke a specific function or a method. Event-driven architecture. Microservices can also use an event-driven architecture where events are used to communicate between microservices. When a specific event occurs, one or more microservices can be modified to perform a specific action. Service mesh. A service mesh is a layer of infrastructure that provides communication between microservices. It can provide a fetch feature such as load balancing, service discovery, and security, which can help improve the reliability and the performance of microservice communication. Overall, there are several ways for microservices to communicate with each other, and the choices of communication method will depend on the specific need of the application. It is important to choose a communication method that is reliable, scalable, and easy to implement, and that provides the necessary security and performance features. Please like and subscribe our channel so that we can give more informative videos to you. Thank you.